Now we can start with the load characteristics in the power system. These are very important regarding objective type of questions, and each and every formula of this is very important. So please remember the formula when we are going through the load characteristics. So first of all, we will start with the demand factor. What is called as the demand factor? It is the ratio of maximum demand to the total connected load. So it is equals to one can see that the demand factor goes high with increase in the total connected load. If the load increases, then the demand factor is low. Whereas if the maximum demand is increasing, the demand factor increases. So one should understand the formula for the demand factor, that is called the load, maximum load divided by total connected load, or the maximum demand divided by the total connected load. Another thing which we should understand in the load characteristics is called as the average demand. What is called as the average demand? Average demand is defined as the ratio of energy consumed in the period to number of time or number of hours in that period. So we can write average demand as the energy consumed in that period divided by the hours in that time period. Energy consumed in that period divided by the hours in that time period. What is the significance of the average demand? So the average demand is the demand which is always present in the system. So energy consumed in that period, if we are talking about the 24 hours suppose, so energy consumed in 24 hours divided by the 24 hours is called the average demand for 24 hours or 1 day. So we can have average demand for day, we can have average demand for hour also, for day also, for week also, for month also, for year also, for a decade also. So average demand on a system is likely to be changing with respect to if we are going towards the decade rather than going for the day. So for a day, average demand will be very much fluctuating. For a month, it will be less fluctuating. For a year, it will be less fluctuating, and for a decade, it will be very much less fluctuating. So after getting the average demand of the system, we can have a power system design, or we can have a power system generating plant according to the average demand, and according to the demand factor also we can have the total system capacity, how much system capacity should be there for a city or for a state or whatever. So for a particular period, a particular community, we can have the demand factor and we can have the average demand too. Third thing which is very important, which is called the load factor. Load factor is defined as the average demand divided by the maximum demand. So we can write load factor as average demand divided by the maximum demand. So this load factor on any power system should be as high as possible. As high as possible means if it is on 100% basis, then if the load factor is 100%, then it is well designed system. But normally, when we are considering a power system generating plant, it is never lower 100% because average demand to the maximum demand cannot be 100%. So average demand is always fluctuating, as we have seen in the graph of load curve, that and the load curve as well as in the load duration curve, we have seen that the demand is always changing according to the time, according to the way of the work which the person is doing. Even you and me also do the same thing, and average demand for you and me also changes every day. So according to that, and sometimes the maximum demand is at the evening for normal customers, normal consumers, for household customers. But when it comes to the commercial customers, normally 20 hours in 24 hours when the factory is working in the morning times, then the maximum demand at that time is there. So their load factor is high at that time. But when the factory or when the system is closed in the night, then the average demand for them is very much low. So thereby we can say that the load factor is never 100% for any customer. So load factor should be as high as possible, so that the demand of the system or the capacity of the system can be classified according to that. Coming to the diversity factor. One more thing is called as the diversity factor, which is equals to the actual energy produced. Divided by the total energy that could have been produced. So the diversity factor exactly is the actual energy produced in the system, and the total energy that could have been produced is called the diversity factor. So we should have the diversity factor as high as possible. The diversity factor should be as high as possible. One thing in diversity factor is that what is called the diversity. In a normal understanding, what is called the diversity? We say that the actual energy produced upon the total energy that could have been produced doesn't mean much to a person which is new to power system. So we can have one thing. Again, coming back to the load curve. This is load versus time. Suppose for a place load curve is somewhat like this. or I can say not like this right now. This is the load curve for a place. Suppose any city. So this is the load curve where we can see that this is the minimum load always present in the system, and so I can have a power plant, generating plant of this system. But if I have the power plant of this system, what will happen? I will be able to cope up this much of energy, no issues. But apart from that, this energy will not be, my system will not be able to cope up with this much of energy which is above this dotted line. So what to do now? Either I have to increase my installed capacity, either I have to take it from some other interconnections. So if it is a hydro plant, so I cannot increase the height of that, so the power generated will not be increased. In the case of my thermal plant, I have an option of using better coal, better type of coal for increasing the installed capacity, or I can have the more number of working hours in the system, or I can have interconnection system, so that this much which is above the dotted line, which I can take from some other interconnections. But that will not also help us. The way, because of the reason that if I say this is almost at 8 p.m. in the night, suppose at the 8 p.m. in the night every day I am getting a lot of consumption of the power. Let it be being from the commercial person, let it be being from the household person. So at 8 in the evening, then there is a lot of power which is required. Now, suppose I have an installed capacity like this, rather than the previous dotted line, so what will happen? Now my installed capacity is increased, so I'll be able to produce that much of electricity which is below this dotted line. But still, I have to take this much of energy from some other place. And one also can see this thing that here I am not using my installed capacity. This is the blue line which is shown over here, as well as blue line over here also. I am not using this much of installed capacity. Which is being always wasted, So I should be having a diversity in the load to increase my load factor first of all. And if I increase my diversity factor such that according to this, if the area of this red triangle, it's almost a triangle right now, is almost suppose 100 square centimeter. If this is almost 100 square centimeter. So if I do one thing, rather than having this much of peak, if I am able to have somewhat like this, or I can have a graph of somewhat like this, which is also equivalent to 100 square feet right now, or 100 square centimeter, which we have spoken about. And this was my installed capacity at that time. So at that moment, what happens that rather than everything going on 8 p.m., everything maximum demand under 8 p.m., I have a maximum demand of almost this much thing at the stretch of time. So what will happen? So my installed capacity at this time will be fully utilized. As we can see this thing, that only this much of area is getting wasted. Previously it was somewhat like this, and previously it was somewhat like this. I am able to utilize this much of area which is coming now under my load curve. Or now I can have a system which is almost starting from here and going up to here. If I have a graph like this for the load curve, and this is almost my installed capacity, which is the dotted line shown over here. So I can have this much of only wastage here. I'm not having any wastage. So what will happen, since the wastage is low and the diversity is more, so the wastage will be lesser. One more thing which comes here, that the maximum demand is low right now. So if the maximum demand at 8 p.m. right now is almost the same, which is at this holding, so what will happen, that the installed capacity of my system will come down. First thing, if I want to design a system so that the maximum demand is fulfilled at that time, since now the maximum demand is low, so total maximum demand is low and my diversity factor is right now high. At that time, my stretch of my system would be high and my capacity of the system is fully utilized. So at that time, my diversity factor is high. So at that time, energy which is actually producing and the total energy that could be produced is almost same. So the diversity factor is high. So I should be having a diversity factor as high as possible. So I should be having the load factor should be high and diversity factor should be high. And one more thing which is coming right now is called the Planck